Today we're going to look at domain and range. Domain of a function is all the things you can put in to get something out. So for the domain of, domain of 1 over x is all the values for which 1 over x gives you a reasonable output. So if we actually look at this on a graph, 1 over 1 is 1, 1 over negative 1 is negative 1, 1 over 2 is exactly that. 1 over any of these numbers is going to literally just give us 1 over that number. And then 1 over 1/2 is 2, and so on and so forth up this line. So as we get closer to 0 here, we're going to get bigger and bigger numbers. And as we get a larger number, we're going to approach 0 on that side. Same is going to be true for negative numbers. But let's just start at negative 0. We're going to have, actually we'll start at 1, and the closer we get to 0, the further down it goes. And the closer we get to infinity, the further up it, or the closer it gets to 0 there. So the only value for which we can't actually define the answer is going to be 0, because we don't know whether we should put it at positive infinity, negative infinity, some weird way in which it could somehow equal 0, or something in between. So the domain of this is going to be everything here and everything here. So we're going to just put it in an interval, which is going to be a value here, minus infinity up to 0. Notice these parentheses. These mean really everything you want as long as it falls inside here, but we can't actually get the endpoints out. So we can't put in 0, and we can't put in minus infinity, but we can put in anything in between. And then we're going to write this little happy U for union. It doesn't actually need these little I's, but I'm going to give it some. Union, so it's smiling because it has friends, with 0 all the way up to infinity. Now if you look at this from a more, like just on the surface, it looks like this means everything. But it can be anything between 0 and infinity, and it can be anything between minus infinity and 0. But what it can't be are 0, minus infinity, or infinity. So this just means everything but the end points. So the domain here is going to be any number on this line but that one. If we want to just kind of flip the script for a moment and look at range instead, then the range of this function is going to be of 1 over x is going to be the same, because over here we have everything between close to minus infinity as we want to get, all the way up to as close to 0 as we want to get. And we're also going to go ahead and say we have everything from as close to 0 as we want to get to as close to positive infinity as we want to get. But again, we can't get any of those things, because if we had a value for which y was 0, would it be this one, both of them, neither of them? We can't actually get there as much as we want to try, because anything we plug in is going to have a reciprocal that we can flip back over to get itself. So let's actually look a little bit more carefully at specific functions that have domains and ranges that we can actually work with and look at. So let's try the function y equals x squared. I'm going to have to erase some of these lines from the 1 over x portion. And instead provide the happy little parabola that we all know and love right here. So from here, we know that this extends on in both directions going up. So we can say that the range can get as close to infinity as it wants to. And it equals 0 right here, but it never gets any lower. So range of this function is anywhere from 0 to infinity. But since it can equal 0, we're going to go ahead and put a square bracket on here, because that means everything from 0 to infinity, but we actually want to keep this one. So whereas before we couldn't use the 0, so we had to write it with one of these. And at the same time, we can look at a function whose domain is more restricted by taking, for example, a log function. By the way, at any point, if it looks like I'm erasing things too quickly, feel free to pause the video and look at whatever I had previously written down. So let's go ahead and check out a log function. So log base 2 of x minus 2. If we ever have an x value, let's actually plot a couple of points of this first. We have 3 gives you 2, or 3 minus 2 is 1, so log of that is 0. 4 is 2, so log of that is 1. Again, we have 6 gives you 4, so log is 2. And 10 gives you 8, so log of that is going to be, sorry Pikachu, 3. And then as we get further and further down, we're going to get closer and closer to this line here, giving us something that looks a lot like this. And what we have here is a vertical asymptote, meaning the domain, the x, can never get to this particular line. But also because of the way log functions work, where you can't have a 0 or a negative, it can't be anything to the left of here either. Meaning the domain of that function is anything greater than 2, and obviously it can't be equal to infinity because that would have some weird stuff go on, but it can be as large as you want up to that. And the range, on the other hand, anytime you plug in a y value, you could get back an x value for it, meaning that if you sent that all the way towards infinity, that would eventually give you an infinite y value. So the range of log base 2 of x minus 2 is negative infinity all the way up to positive infinity. And that's because also you can get as far down as you want the closer you get to x equals 2. I'm sure more questions will arise as we spend time together in class, and when they do, feel free to ask them, and I will explain them in as much or little detail as is necessary on the board. But until then, have a good one.